All right, a very good afternoon to all students who are online now. Okay, we are actually doing this seminar. At the same time, we are also doing live on Facebook. If you are having any difficulties of your internet connection and so on, we are actually, you can go to our Facebook page so that you can watch the live at the same time also. Okay, so Facebook, as I can see, some of you are choosing to stay on Facebook because of a stable internet connection, and some of you already joined our Zoom meeting. So as you know, this is the second meeting for this final touch-up for physics. And we know that tomorrow is the first day of your SPM, Bahasa Melayu. And I hope that all of you are well prepared. Okay, the purpose of us doing this seminar is to help you to prepare this physics paper, although it is still another month times for you to sit for a physics paper, okay? Without any further ado, I think I should invite Mr. Lee because all of you are actually wanted to do revision for your BM paper tonight. So let us welcome Mr. Lee so that we won't drag on any more time. Yeah, what?
All right, thank you, Mr. George. A very good afternoon. All right, welcome to everybody who is about to sit for your first paper tomorrow. All right, and I guess you are pretty prepared. Okay, you should be prepared because SPM has been postponed. You have extra, okay, 2 or 3 more months. Yeah, as a matter of fact, I think it's December, January, and February. All right, is approximate more than 3 months, so you should be well prepared for your SPM. So without much delay, we are going to look at I told all the students that I'm going to do prediction. So I'm going to inform you what you're going to do, but probably not now. I go into the real picture in the middle of our revision today. All right. But as what I mentioned the other day, question number 1, my prediction is going to be okay, on inertia. Okay. All right. Question number 1, I predict it is going to be inertia. All right. Okay. Inertia will come back. Okay. Inertia, question number 1. All right. Then you're going to make use of the hexaw blade and so on. All right. Soalan pertama. All right. Soalan pertama will be inertia. All right. And question number 2. All right. It will be on electricity. Okay. So you going to this year, I make a very strong prediction. That question that uses iron York, the C iron York, okay? All right, C iron York, all right? And then we want to see how far the displacement of the copper rod will move. All right, this is example of the what that will come out, okay? So this is going to be the prediction for our paper 3. Boleh? All right, prediction of our paper 3. If you have any question to ask, please do so. All right, and I have been giving prediction for the past 12 years, and all the prediction are accurate. Of course, sometimes it's not 2 questions that I predicted came out. It could be only 1 question. All right, it's already good enough because you are expected to do only 1 question. Is that correct? All right, you're expected to do 1 question only. Sudah mencukupi. Now, we go into the detail afterwards. Okay. All right, I will go into the detail afterwards, and let's get start with our first slide of revision today. All right, which is supposed to be a Form 5 syllabus. Okay, let's take a good look. All right, so let's take a good look at this question number 8. Diagram shows a fishing boat use, all right, the pulse of solar. All right, okay, pulse. So there's just a spelling error here. Okay, it should be POL. Okay, POLSES. Okay, pulses of, all right, solar to detect a school of fish. All right, and diagram B show a bat uses ultrasound to navigate in the dark. What is meant by ultrasound? Okay, 1 mark only. All right, so among the answer given by candidate, all right, okay, it is said greater than that of audible sound. All right, greater than that audible sound is not very accurate. It should be above our hearing limitation of human. All right, which is more than 20,000 hertz. Clear? Higher than the upper limit of human hearing, which is about 20,000 hertz. That is a proper answer. Clear? All right. Of course, some students will just write the answer ultrasound is referring to sound with higher frequency, full stop, and that is also not accurate or good enough. All right, so make sure you know this. Okay, and then we're going to go to section B, identify the similarities of the waves. Okay, so we know that we uses ultrasound, okay, to detect the presence of the school of fish in the first diagram, which is diagram A. And diagram B, you notice there's a bat that will transmit ultrasound. When it hit the hard surface of the cave, it will bounce back. Also, it is going to use ultrasound. So they ask you to compare the working principle. Okay, so we know that the working principle that you must highlight, the keyword number one, it would be the what working principle involved, which is reflection of sound. Let's take a look at the answer given by the students. All right, concern. Okay, let's take a good look. All right, okay, statement number one say that the fish, okay, the school of fish, all right, can detect, okay, can detect this, can detect the reflected sound, all right, and both navigate by night, all right. So these are very, we call it lame, very lame answer, and then it's telling you sound waves are longitudinal, and the speed of sound is affected by the density of water, all right. And okay, perhaps the last point is accepted because the time for the ultrasound to travel, all right, to and fro, determine the distance between the signal source and the reflecting. Let's take a look at the more accurate answer. All right, so you need to talk about both of them are using the system known as sonar. All right, remember sonar? Sound, navigation, and ranging. Okay, S for sound, all right, N for navigation, all right, okay, all right, SO for sound, all right, SO for sound, NA navigation, all right, R will be ranging. Ranging means how far or how deep. All right, so your first statement, it says that both use an ultrasonic technique, which are waves with high, understood, you need to put the word, okay, keyword high frequency, all right. Both sound waves are blank, which can travel through medium, all right, okay, longitudinal waves, all right. And the waves undergo, we know, okay, you need to use the word reflection, agree? All right, when they hit the surface, and the time taken, all right, for the sound wave to return, because you need to explain the working principle. And the time registered is used to determine the distance, all right? And then you need to explain also, all right? The longer the distance, all right, what does it mean? Therefore, the time taken for the sound to be reflected will be longer, agree? All right, you can do it vice versa. You can write, okay, the time first, put in front if you want to. All right, you put a time in front if you want to, and then you put the distance at the back. Okay, if you want it to be the other way around. All right, it's not a problem. Okay, it's not a problem. Boleh? Okay, that's what we do. All right, let's move. State the relationship between loudness and the amplitude. Now, this is actually a Form 3 question. We all know the higher the amplitude, the higher the loudness. Agree? All right, and take a good look. Oh, actually, you are given diagram. Okay, you are given diagram. Okay, sound A and sound B. All right. This student mentioned that amplitude of sound A and sound B is the same. All right. So definitely, when they are the same, you are wrong. Agree? So based on diagram, we know that the amplitude of sound A is much higher. All right, compared to the amplitude of sound B. All right. So understood. Sound A, okay, which has a higher amplitude, will have higher loudness. Agree? So you need to mention specifically sound A has a higher amplitude compared to sound B, and it has a higher loudness. All right, or louder. Okay, the bigger the amplitude of the sound wave, the louder the sound. All right, that will be a better answer. Let's move. All right, state the relationship between pitch and the frequency. This is also a Form 3 question. All right, so understood. We know that. All right, you know that when the pitch is higher, meaning what? The waves are closer. So we all know that sound wave A, all right, has a higher frequency, all right, because the tempo is shorter. Agree? All right. Okay, let's take a look, okay, at the answer given. So when this student mentioned sound A is the sound of a higher pitch, all right, okay, it is not going to be very convincing. All right, it's not going to be very convincing because you need to do some explanation. Clear? All right, frequency of sound A understood is going to be higher. All right, okay, the sound B, the higher the frequency, understood, the higher the pitch. All right, because they ask you to state the relationship. So you need to mention, all right? Okay, state the relationship whether, all right, whether variable A goes up, what happened to variable B? So variable B can goes up, or variable B can goes down, or variable B can be constant. All right, you need to mention this. All right, so this is mentioned already. All right, the higher the frequency, all right, okay, the higher the frequency, then the higher the pitch. I already mentioned here. That's how you get the marks. All right, let's move. All right, Donkey, as an engineer, you are asked to set up a public address system for a concert hall using relevant physics concept, suggest and explain the design. Suggest and explain the design that, right, and modification that can be made to produce a loud and clear sound. All right, your suggestion include, all right, suitability of the interior design to reduce the effect. Okay, effect of what? Let's see. All right, and then the arrangement of the speaker. All right, arrangement of the speaker. All right, and then this is what the students were saying. All right, okay, let's take a good look while you see a sour face here. All right, okay, it's talking about, okay, high quality speaker. All right, and it's talking about microphone is installed far distance from the audience. All right, microphone, the focus is on my microphone. Sitting area is arranged near, okay, arranged near to the speakers. All right, carpet is used for the flooring, and the plastic layer is placed in front of the hard wall. Let's take a look at the better answer. All right, so you are going to say, all right, you're going to talk about louder, right? Okay, and better reception. All right, then you're going to use the word, all right, not high quality, okay, higher power speaker. Always remember, higher quality, the word quality cannot be used, okay? High power speaker, then understood, produce loud and clear sound. Clear? Speakers are not installed facing each other. We are not supposed to, all right, install the speaker facing each other to prevent multiple reflection. And the speakers must be installed far away. Why far away? This is what you have learned, right? This formula that you learned, I hope you remember, lambda equals to AX over D. When you cross multiply, you're going to have a, all right, lambda D equivalent to AX. All right. So what we have, if I make the lambda and the A constant, all right, not A constant, okay, it's going to be D constant, right? D constant. So in order for us to have lower, okay, lower or nearer distance between two consecutive sound, then the speaker must be placed apart, okay, away from each other. That's why your answer, speakers are installed far from each other, so that the distance between two consecutive antinodes become nearer. That is your value of your X, okay, value of your X. Boleh? All right, glass use must not be fragile. All right, okay, must not be fragile. Why? Because when fragile, all right, sound with high frequency may break the sound, may break the glass. All right, and then we have the sitting arrangement. All right, we must arrange it along the antinote lines. Okay, remember antinote? This is a place where what? Constructive interference occur. All right, so that louder sound can be heard. And carpet is used. Carpet, understood, it will reduce reflection of sound. So these are the example. All right, these are the example of answer that you should be giving. All right, to ensure that you are able to give a better answer. All right, let's move to the next one. All right, this is we are moving towards chapter electricity. All right, and electricity is one of the prediction of question that I predicted. Okay, that I predict will come out for this year 2020. Diagram shows the setup of a circuit study relationship between V and I. Let's take a good look at your wood meter. Okay, all right, wood meter. All right, I think this is going to be a wood meter. All right, this is going to be a wood meter here. Okay, so that wood meter there is actually placed across the bulb. All right, even though the drawing is not very clear, but it should be clear to you. What is meant by potential? So if you were to answer potential like this, you get 0, huh? All right, okay. You need to explain what W means and what Q means, okay? All right, you want to answer like this, then you will say whereby, all right, whereby W is what and Q is what. You need to explain to examiner. All All right. If not, then marks will be deducted. Clear? All right. Or you write full in a complete sentence. All right. Potential difference is defined as the work done. Okay. All right. As the work, W referring to work. Okay. All right. When one column of charge. Okay. Q will be quantity of charge. So it's referring to one column of charge. All right. Move between 2 points. All right. In an electrical field. Clear? So that's how you answer. Then what is meant by currents? Question number 2. Okay, many people will answer by using what you learned in Form 3. Then you will not. If you were to give answer like this, sorry, no marks is given. You should be giving what you learned in Form 5 level. All right, the rate of flow of quantity of charge. This should be your answer. Clear? All right. Okay, but if again you give answer like that, then it will be better for you to, all right, put in sentence form. All right, sentence form. Electric current is the rate. Okay, it's the rate of flow of quantity of charge. The rate. Okay, the better answer is the word rate. Okay, the better answer is the word rate. Can I continue? All right, next. Potential difference against current. You know that if it is obeying Ohm's law, it should be a straight line that go through origin. It should be like this. All right. But it seems it is not giving you a straight line that go through origin. It's going to be a curve. All right. So you know that, okay, the gradient of the graph, if it is ohmic meaning it obey Ohm's law. All right. Then it will be constant. All right. Which is going to be what? V over R. V over I. All right. V over I. All right. The gradient meaning you're going to locate a triangle. All right. You're going to locate a triangle. All right, and you're going to get the value of the gradient. That actually is referring to the value of the resistance, all right, okay, of the conductor. But unfortunately, this graph is not a straight line, it's a curve, all right? So you notice that the resistance, all right, resistance, they ask you to talk about resistance. We know resistance is not constant, all right, okay, because the gradient of the graph given, all right, here is not constant, all right? If it is this graph, yes, it's constant. So understood. You notice the gradient actually go, okay, at point A, all right? Then at point, okay, probably I put your point A here, point A, at point A, all right? Okay, at point A there, all right? Here is point A, all right? And here is, let's say, point B. So you notice that point B, the gradient is slightly higher. And then at point C, then the gradient even higher. So what does it mean? When gradient higher, understood, resistance is higher. So suggest one way to determine the resistance, okay? So determine resistance, we will get what? Okay, we get resistance by getting the gradient of the graph. Do you agree? This is the basic knowledge that you must know in chapter electricity. Clear? All right, but the student, this candidate, okay, giving the general formula of resistance. All right, you have giving general formula of the resistance, you don't answer that question. All right, I look at the better answer given. All right, okay, it is the gradient. All right, I have just explained. All right, I have just explained at the top there. You notice that I explained over here. All right, I explained over here. All right, it is actually referring to the gradient. All right, of the graph. Okay, explain why the graph is not straight line. You know, we are talking about. Let's go back. Let's go back to the original diagram. Okay, the original diagram, voltmeter is across the bulb, and the bulb get hotter. And what do you learn? When bulb get hotter, temperature increases. All right. When the bulb get hotter, temperature increases. All right. And what do you learn about the relationship between temperature and resistance? What do you learn? All right. What do you learn? As temperature increases, all right, because when you light up a bulb, right, when you light up a bulb, the bulb will get what? Okay, bulb become hotter. All right, when bulb become hotter, understood. What happened is temperature will increase. Betul? All right, temperature increase. And what is the next thing that you learned? All right, when temperature increases, resistance also will increase. All right, because you know that, all right, resistance is directly proportional to temperature. All right, so when temperature increases, all right, when temperature increases, understood, resistance increase. And when resistance increase, understood, gradient also increases. All right, okay, just now we got look at radius. All right, we got look at resistance. all right, is actually similar to gradient. All right. So understood the gradient will increase when resistance increases. Clear? All right. So this student were to answer the bulb is not an ohmic conductor. In a way, yes, but it's not very accurately explained. You need to explain. The resistance of the bulb increases as the current is high enough to heat up the filament, causing the temperature to increase, all right, or to rise. Therefore, the gradient, okay, of the graph, which actually is the resistance of the bulb, all right, increases. That is how you get the marks, okay? All right, you can condense a sentence and make it even shorter. All right, as the bulb light up, temperature increases, and as temperature increases, the resistance of the bulb increases, causing the gradient of the graph to increase. It will be shorter then because you are only given 1 mark. Boleh? All right, let's move on. Let's move on. Find out the current flowing. All right, we know that we have a formula to calculate current. All right, current equivalent to potential difference across R. All right, everybody will know this. You're given the potential difference, you're given the R. Let's take a look at the answer and see what's wrong. So you probably will know unit is, okay, unit disappear, right? That's why you won't get marks. You need to put the unit there. Boleh? All right, easy question. All right, you just put the potential difference at the top. All right, because it's potential difference across resistance. Boleh? All right, let's move. Okay, diagram shows number 2 of electricity. All right, this is a very common question. Let's take a look at the answer. If you answer like this, okay, definitely you will see this symbol. Clear? You will lose your marks. The best answer is you're going to say because you learn the definition of power. All right, okay, it's actually energy over time, betul? Which is the, okay, which is the amount of energy consumed, all right, in 1 second, betul? All right, so that is what you mentioned. All right, you got to tell and inform inform the examiner that, all right, 1000 watt is actually the power and it consume 1000 joule. All right, it will consume 1000 joule of energy in 1 second. All right, okay, 1000 joule of energy in 1 second. That's why we use the word per second. Boleh? That's how you get 1 mark. And all right, what is meant by the power rating 240? All right, if you answer like this, then definitely you are going to be wrong. Okay, so the power rating meaning what? Okay, the kettle will release, then you're going to use almost similar statement just now, 1000 joule of energy per second when connected to a, all right, potential difference of 240 volt. That should be the answer you give. All right, that should be the answer that you give. Let's move on. All right, I hope I'm not doing too fast. All right, okay, let's move on to the next one. State one suitable material that can be used as the heating element. All right, okay, let's take a look at the suggested. All right, they actually wanted you to name the material and not state the characteristics. All right, not state the characteristic. Clear? So you need to tell exactly, okay, what is used. Okay, tungsten. Boleh? Diagram show the kettle of, all right, labeled 240 watt 1000, calculate resistance. All right, calculate resistance. We know that we have the formula. All right, okay, we have a formula to get resistance, or we have another formula for power, V squared over R, betul? All right, so in order for you to get your R, is going to be, you just play with the formula, it's going to be a V squared over P. All right, let's take a look at the answer given. All right. Okay, if you were to use this, then you probably will get yourself in trouble, all right? Because you are using the formula that you learned in Form 3, all right? You should apply, okay? You should apply the formula, okay? You should apply what you learned, okay? The formula I've given to you. Oh, let me see. Okay. If you were to use this, you will do two steps. One is this step, another one is, all right? After that, you're going to continue to get your R. Clear? Which is going to be this. You have to do two steps. But if I were to use this, I'm going to write over here. All right. Okay. Power equivalent to, all right, I'm going to write over here. If you use this formula, it will be only one step. All right. Power equals to V squared over R. And your R equivalent to, all right, V squared over P. So you're going to substitute your V, which is 240. You're going to put at the top, all right, over power, which is going to be 1000. All right, your answer will be exactly what you get over here. All right, there will be a faster way. Boleh, can see, huh? All right, there will be a faster way. One step only. All right, no doubt if you do the what I showed there, it is still okay. All right, it is still okay. All right, you are going to do 2 steps for the formula. Everybody okay? So if you are able to follow, then I'm going to move on. All right, I'm going to move on to look at another one. All right. Okay, let's move. Calculate the cost. This is a little bit similar to what you learn in Form 3. All right. Then a little bit that you learn in Form 3. Let's take a good look at it. All right. Calculate the cost of the electric used in a week if the kettle is used for 30 minutes per day. All right. We don't look at the error, otherwise you'll be wasting a lot of time. All right. You should be using the calculation. All right. Amount of electric consumed is going to be PT. All right, power, you're given the power as 1 kilowatt, okay? Not watt, huh? You're not supposed to use watt, okay? Because you are going to use kilowatt hour, clear? And how many hour? All right, so it's going to be 1 kilowatt and the hour is going to be, it says 30 minutes, okay? 30 minutes meaning what? Half an hour, all right? But in 1 week, okay? 1 week, so it will be, you multiply by 7, all right? Half an hour, 1/2 times with 7, all right? So you multiply, you get a 3.5 kilowatt. And the cost, 1 kilowatt is going to be 20 cents. All right, so you just multiply. All right, because you are getting, all right, you're getting 3.5 kilowatt hour. All right, just times with the rate, 3.5 kilowatt hour. All right, then times 20 cents, you are able to get, all right, you're able to get 70 cents. And make sure, all right, the unit RM you have to put in. All right, let's move. Okay, describe how the current passing through the heating element. This is similar to what we did just now, but the graph is opposite. All right, remember the graph. If I were to draw V against I, all right, V against I, all right, which is opposite of I against V, all right, is going to curve this way, whereby gradient go up. Agree? So remember when gradient go up, all right, what does it mean? When gradient go up, understood, resistance goes up. But when you draw the reverse, then the curve will be the other direction. All right. So what is the question asking for? All right. Describe how the current passing through the heating element changes with potential difference. All right. Let's take a good look. All right. Okay. It says that I is directly. So directly understood is not correct because it's not a straight line. All right. You will say that. Okay. Current. Okay. Increases with potential difference. All right. So in other words, when potential difference go higher, all right, when potential difference go higher, all right, then current will actually also go higher. Okay. I remove my graph. Okay. I remove my graph. The current that flow through the heating element increases as potential difference increases. Betul? That is the right answer you should give. Let's move. All right. Table show characteristics of material used for heating element. All right. These are very common question. All right. Heating element. Okay. You're asked to talk about melting point. You're asked to talk about resistance. You're asked to talk about oxidation level, density, and you have to think of what you are going to answer. Huh? All right. Material. All right. Characteristics of material used to make heating element. So heating element is going to generate a lot of heat. So understood. Heat meaning what? You need to have high resistance. So understood. Resistance must be high. All right. And also, okay. Why resistance high? To generate a lot of heat. So generate a lot of heat, it must have a high melting point. Do you agree? All right. And then we don't want the heating element to get oxidized. Otherwise, get oxidized meaning what? It will not become metal. All right. You learn in chemistry, metal plus oxygen become metal oxide. All right. Metal oxide is going to be ionic. Okay. Ionic compound. All right. And the ionic compound, it will not conduct current anymore. All right. It will not conduct current because they cation and anion, they are not free to move around. Okay. And understood, density, we want it to be low. All right. Density, we want it to be low. Oxidation also low. So the first two characteristics, it must be high. The first The last two characteristics must be low. Let's take a look at the answer given. All right. Okay. So you know that this is a mistake because it mentioned low. All right. Okay. And let's take a good look. All right, at the answer. All right. But at a glance, we know. All right. At a glance of the choice. All right. Let's take a good look. Okay. High melting point. All right. High melting point. So if it is high melting point, we probably put a tick there. Sorry, we go back. All right, we put a tick there. We put a tick there. Resistance high, then we're going to probably put a tick there also. All right. Okay. Resistance must be high. All right. This is also high. Hang on. Okay. Hang on. We come back. We come back. All right. This is also considered to be high. All right. Okay. Oxidation level, we want it to be low. We don't want to get oxidized. All right. Or moderate. Betul? All right. Density, we want it to be low. Okay. Let's take a good look. All right. Let's take a good look, and you'll be able to see how the answer going to be. All right. Okay. Do you notice or not? The first two, it must be high. The last two must be low. Boleh? All right. Element. All right. Okay. Element. Okay. So, okay. Let's take a good look. Element can withstand high temperature. All right. Able to withstand high temperature. It does not melt easily. Understood? High resistance. Why? Because it wanted to produce a lot of heat. All right. Current flow through it will produce a, all right, big amount. Okay. Big amount of heat. Why? It is used as a heating element. Low oxidation to prevent oxidation. All right. So that it may last. It may last longer. Low density. All right. To make the kettle, okay, lighter. Agree? All right. So that it can be, all right, portable. So if you look at the choice selection will be material key, and then you will repeat all this one more time. All right. So basically, I think most of you will be able to answer a question like this. All right. Let's move on. All right. This is another question. Also electricity. So as my prediction is electricity. All right. For paper 3. That's why I'm going to give you more electricity question. All right. More of electricity question. Let's take a good look. Okay. Diagram show a bulb being connected to a 12-volt car battery. All right. You see here, first diagram A, longer wire. All right. And diagram B, shorter wire. All right. Shorter wire. Understood. There, the bulb become brighter. Longer wire, bulb become dimmer. So understood, you know, it's talking about what? It's talking about, the longer the wire, the higher the resistance. The higher the resistance, the lower the current. Betul? Lower the current, right? Lower the current, that's why the bulb become dimmer. All right, now inference asked must be based on diagram. All right, then this student put the word thickness. Definitely is wrong because we are not talking about thickness, we are talking about the length. Agree? All right, so understood. All right, okay, the brightness. You must put the word brightness because the examiner have given you, all right, okay, the difference between the two bulbs. One is dimmer, one is brighter. All right, one is dimmer, one is brighter. Though you must be talking about the brightness. The brightness of the bulb is affected by the length. And so one is longer, one is shorter. All right, let's move. With the use of apparatus, you know that we're going to write all this. All right. So the student were to write, okay. All right, what's wrong with this answer? Okay, I'm sure you know, right? You are not able to measure brightness. So you are not able to measure brightness. The moment you put the word brightness, then you are going to lose marks. Boleh? All right, you are not able to measure brightness. The moment you put brightness, then sure you lose marks. All right, you are not able to measure. All right, you are not able to measure brightness. You are not supposed to put brightness. All right, variable meaning something that is what? All right, something that is measurable. All right, with number and with unit. So brightness is not. All right, that's why you need to change it to something that you can measure. All right, isn't it? Something that you can measure. Of course, you can measure length, okay? But the quantity that for you to measure, all right, in a proper way is going to be resistance. Clear? All right, resistance. Okay, resistance of the wire. All right, understood. To measure resistance, you need to have what? Ammeter. All right, you need to have what? Okay, ammeter. You also will need to have what should I say? Voltmeter. All right, and no, sorry, this A is not emitter. This A actually is a symbol that represent diameter. Okay, right? Diameter of the wire that you use and also the temperature. These are the constant. All right, these are the constant. All right, these are the constant D. Okay, the diameter represented by symbol A. Huh? All right, it's always good if you would put the symbol. All right, I want you to make it a habit. All right, when you mention length, then you put a comma with the L there. Actually, there's a L, but covered by the diagram. All right, then R, comma R. A resistance, comma R. Okay, diameter, comma A, temperature, comma T. Can I move? All right, next. Okay, suitable. One suitable hypothesis. Again, all right, even hypothesis, you are not supposed to put brightness. All right, again, all right, it must be measurable. So understood. Okay, you use back what you have chosen, resistant. All right, the longer the wire, the higher is resistant. Agree? All right, and sentence for hypothesis must be like this. The higher, all right, all right, all right, the higher the something, all right, the higher the something, all right, the higher the manipulated variable, all right, the higher or the lower, all right, responding variable. Boleh? That is a sentence. All right, you must have at least two the, all right, the higher and the lower. Okay, the higher the A, the higher the B, or the higher the A, the lower the B. Boleh? So we can measure resistance. All right, that's why we're going to use resistance, something which is measurable. All right, can we continue? All right, so the aim, all right, the same problem, which you are not supposed to put the word brightness. All right, it will be resistance. All right, it will be resistant. Okay, length of the wire and is resistant. Boleh? All right, I always want you to put manipulated variable in front, huh? All right, and responding variable at the back. It's always like that will be better. All right, you want to be more specific, resistance of the wire. All right, the length of the wire and the resistance of the wire. Boleh? Let's move. All right, list of apparatus. Okay, you notice that we have the bulb. All right, you know that it is not a must to use bulb, right? Is that correct? The bulb will make your resistance of the circuit become higher. All right. Instead, you'll probably use some wire. Okay, constant wire. That will be a proper answer. All right. You'll be able to use constant wire. Will be better. All right. It doesn't generate a lot of heat. That will cause the resistance of the circuit to increase and affect your reading of your voltmeter and ammeter. All right. So what's wrong with this? Let's take a good look. What's wrong with this compared to this? All right. Then we need to have the presence of rheostat. All right. The presence of rheostat so that we can change. All right. We can change the reading of ammeter and voltmeter. Clear? All right. We can change the reading of the ammeter and voltmeter. Clear? All right. In order to get the resistance. All right. You need rheostat. Okay. If you don't have rheostat, you are not able to get a pair of reading, different reading of ammeter and voltmeter. Boleh? Okay, let's move. All right, a constant wire. This answer understood. Let's see what is wrong. Let's see what's wrong. All right, let's see what's wrong compared to the correct answer. All right, okay. Here it doesn't mention. It just mentioned. All right. A better answer that you should put is okay. I'm going to put a line there. Sorry, I'm going to put a line there. All right. So you need to mention constant wire 10 cm is connected. Ammeter reading, you must mention. All right. And voltmeter reading, you must mention. Oh, yeah. Okay. You only, this one, they only instruct calculate resistance. All right. Calculate resistance is not mentioned specifically. All right. How to get the value of resistance. It'll be proper for you to tell examiner. All right. It's the reading between the what? Voltmeter and ammeter. All right. Voltmeter reading over ammeter reading. All right, that's why the symbol V over I, and as usual, okay, above steps are repeated, use different length, okay, different length, and corresponding value, okay, all right, is of resistance is calculated. Boleh? All right. So the way you tabulate, understood, okay? You could see that the word brightness will take away your marks. Betul? All right. The word brightness take away your marks. All right. Since you are using length, since you are using length, right? Since you are using different length, okay, length as your manipulated. So make sure you have different value of length, huh? Make sure, huh? All right. Sorry, I go back. Different value of length. Mesti ada, huh? And you know your responding is resistant. All right. Responding is resistant. Make sure you have resistant. All right. But in order for you to get resistant, you must have a set of reading, word meter reading, and ammeter reading. All right, which you label as I stroke ampere, V stroke word. Boleh? Okay, let's move to the next one. All right, let's move to the next one. Okay, and understood the way you analyze. Okay, manipulated, understood is here, responding is here, but you see the sour face here because you are not supposed to show the line. Betul? Right? So the correct answer it should be just a naked graph only with the axis of y-axis and x-axis. That's all. But make sure manipulated is correct. Manipulated length. Responding variable resistant is correct. Of course, it will be better for you to put the unit stroke ohm. All right, here is okay. Stroke cm. Boleh? All right. And I'm going to hang on. I'm going to look at how many slides we have covered so far. All right. Okay. I'm going to do one more question before I look at your. All right. This is slide 203, and I will go through this. All right. Before I end and look at. Right. Look at what should I say? The next one. All right. Okay, I'm going to look at this first, then I will stop and we look at the prediction of the question. All right. Okay, I will do it in the middle I just mentioned. All right, let's move to number 4. This is going to be electromagnet. The following chapter is no more electricity. All right, let's take a good look. Okay, this is also paper 3. So it seems that I focus a lot on paper 3, right? Because paper 3 is the one that will determine whether you're going to get A plus or A minus or A, or probably B and so on. Boleh? Right, diagram shows a speaker which contains electromagnet. When a speaker is connected to power supply, a weak sound is produced. All right, weak meaning soft. All right, and then loud sound is produced when the speaker is connected to the bigger power. Okay, all right. So understood. One loud, one loud, one soft. Clear? All right. Then suitable inference. Okay. Why is this not accepted? Okay, because you are not supposed to use scientific terminology. All right, you're not supposed to use scientific terminology. All right, okay, you may use the word, the magnitude of the sound. All right, okay, or the word loudness. Why the word loudness is okay? Because you are given the word loud. Okay, one word loud, one word is weak, which is soft. So loudness is okay. All right, and this is accepted because it's given. All right, it's given. All right, the word power is given in the question. All right, the word power is given in a question, so you can use. All right, the word loud and the word soft. Okay, the word loud and the word soft. Okay, here is soft and here is loud. That's why loudness can be accepted. Boleh? Loudness can be accepted. Right? Okay, loudness can be accepted, and the word power, the size of the power of supply affects the loudness of the sound or the magnitude of the sound. All right, variable in the experiment. Okay, understood. Okay, variable in the experiment. All right, you take a good look. Okay, these candidates simply put number of turns, but in the question, it has got nothing to do with number of turns. Clear? All right, it will have to do with power. But power, you know, power is governed by VI. So what's the best thing is? You will change the current. Understand? In order for change of power, you change your current. Boleh? Voltage or potential difference you cannot change. All right, the supply to your house in terms of potential difference, all right, or wattage is always the same, 240. You can only change what? All right, you can only change the current. by changing the current, okay, you are actually changing the power. Boleh? So the current they flow, all right, to the coil, that is a manipulated. Responding, understood, all right, is going to be loudness, but you cannot measure loudness. So how do you measure? You measure the strength of electromagnetic force, all right, but you also cannot measure directly. So that's why you're going to use representative number of pins attracted, number of pins or number of paper clips attracted. If you use pins, then you write pin. If you use paper clips, then you write paper clips. Boleh? Boleh? All right. And the other constant variable, number of turns in the coil, yes, like diameter, thickness, cross-sectional area of the coil, yes, all accepted. All right. Then we're going to go on, okay, to one suitable hypothesis. All right. You notice that we have chosen this word, huh? Current. You have to repeat current. All right. And we have chosen the word, okay, strength of electromagnetic force. You can use back these two. Boleh? All right. Okay, you must use current. You're not supposed to use, all right? Okay, you're not supposed to use others. Okay? The greater the current, all right? This sentence is not, okay? It's not the sentence you normally use for hypothesis. Remember the sentence for hypothesis? You have a lot of the, all right? The greater the current that carried by the coil, the greater, right? The greater or the bigger the strength of the magnetic, okay, electromagnetic. Boleh? All right, let's move. Okay, the aim of the experiment. Okay, so you notice that this is wrong. It should be current, betul? Manipulated should be current. All right, therefore your answer that you're going to give, all right, you'll find out the relationship between current, manipulated, all right, okay, and the strength of electromagnetic force. All right, yes, we know it cannot be measured. All right, we know this cannot be measured, but you got mentioned. All right, you are going to use, okay, representative. It's okay because you got mentioned there. All right, in your responding variable. All right, it can be represented by the number of paper clips attracted. All right, and let's take a good look. Okay, what's wrong with this as compared with the correct answer? All right, as compared with the correct answer. Okay, what is missing? All right, we have the coil. All right, we have the copper wire. We have the coil, insulated coil, copper wire. We have ammeter. Okay, all right, we have dry cell. All right, we have the switch. We have the paper clips. What is missing then? We have the retort stand. All right, what is missing there? All right, we have paper clips. Okay, see what is missing there? Yeah, rheostat. All right, rheostat. The why do you need rheostat? Always remember when you change your current. All right, when you change your current. All right, when you change your current is your manipulated variable. All right, you cannot just change as you like. You need to use something to help you to change. That something is none other than rheostat. Understand? All right. You always use rheostat to change the current. Clear? All right. By adjusting the rheostat. Clear? All right. So without rheostat, understood your drawing is wrong. This drawing you notice without a rheostat. So you need to show the presence of rheostat here. That's how you get 1 mark. All right. For the arrangement of apparatus. And let's move. All right. Procedure. All right. Okay, you take a good look. This student would simply put the value 1 ampere is pretty too big. Okay, too big. And this is, again, you mentioned this, not measurable. You should mention the number of paper clips attracted. All right, so not measurable. What do you see here? 3-letter word, die. Boleh? All right. So when you mention 0.1 ampere, make sure in your table of, okay, table of tabulation, your first value of current must be 0.1. You must follow. All right. Then solenoid is lower to the paper clips and the number of, understood, paper clips attracted. Okay, it's recorded. Then procedure repeated. Okay. All right, repeated. Then you increase it to 0.2, 0.3 ampere, 0.4 ampere, and the corresponding, understood, number of paper clips attracted is recorded. Okay? All right. Number of paper clips attracted by the solenoid or attracted to the solenoid. All right. Okay, let's move. Is it okay? I believe I didn't go too fast. All right. We have spent 45 minutes approximately. All right. Okay. The way you tabulate, remember 0.1 ampere? You see, this is pretty too big. Okay, you are telling examiner you never do experiment. Clear? 0.1 until the bigger 0.5. All right, and you cannot write the word strength. All right, you cannot write the word strength of magnetic. Why? It is not measurable. All right, cannot write the strength. You can write the number of paper clips attracted. All right, and the last one will be the analysis. All right, okay, the last one will be the analysis. Hang on. All right, okay. So what is missing? The word strength. Okay, the word strength you are not supposed to put. Okay, you're supposed to put what? Okay, you're supposed to put number of paper clips attracted. Boleh? All right, because one is not measurable, one's okay, is not measurable, one is measurable. Boleh? All right. So if that is okay, we are going to look at. All right, we are going to look at. Paper 3 now, huh? All right. We're going to look at paper 3. I'm going to talk about the first question that come out. All right. I'm going to talk about the first question that come out, and let's move away from here. Hang on, I come out from this slide first. All right, afterwards we will come back here. All right, okay, my prediction for question, all right, number 1, I just mentioned is inertia. Let's take a look at the question of how the question of inertia will be like. All right, how the question of inertia will be like. All right, so question of inertia in the past, they show you many, okay, in the past. All right, in the past before, okay, they show you many. All right, the one that came out before I show you is talking about trishaw. All right, one person pulling a trishaw. All right, hang on, this is PDF. Okay, PDF. All right, let me get the. All right, okay. Question on trishaw came out. Remember, trishaw is showing you, one person pulling a trishaw. Okay, I just simply draw with one passenger. All right, one passenger. All right, trishaw. Okay, all right. Okay, I simply draw a trishaw. All right, with one person pulling it. Okay, and then another diagram is showing you. All right, 3 person. All right, it's showing you 3 person in the trishaw. All right. So understood is giving you the idea 3 person in a trishaw. All right, it is going to be pretty heavy. All right, pretty heavy meaning what? Bigger mass. Betul? All right, bigger mass. So bigger mass, the threshold will hardly move. Okay, the threshold will hardly move because the person who push is still one person. All right. So anyway, we know it's talking about diagram on the left, lower mass, diagram on the right, higher mass. All right. All right, and lower mass will give you lower inertia, higher mass, higher inertia. So understood, we are talking about the experiment which is related to inertia and mass. And you know pretty well that inertia is directly proportional to mass. All right, everybody know this, betul? All right. So this question, if you were to read, it say that bell blade is a blade that actually, that will rotate. One attached to one piece of heavy metal, another one show you attached to 2 heavy metal. So it's going to tell you, if you cannot identify, it's a question. All right. And normally they will tell you. All right. In the past, they also have given you a question about the top gasing. All right. Satu gasing. All right. They give you 2 gasing. Alright, satu gasing, alright, gasing biasa yang berpusing. It takes shorter time to stop, and the other gasing yang berpusing, alright, it takes longer time to stop, because they tell you there are stripe. They put what we call stripe of metal stripe here. There are metal stripe here. So the presence of the metal stripe will make the top, alright, a gasing, alright, it will make the gasing to have higher mass. So understood the relationship that we talked about just now. All right, the higher the mass, all right, the higher the mass, the higher the mass, right, the higher the inertia. Clear? That's why, all right, the top with the higher mass, understood, they will spin. All right, the top with the higher mass, understood, all right, will spin. right, for a longer period of time. And the one, right, with the lower mass, all right, okay, the one with the lower mass, this one with the lower mass, understood, okay, will spin, all right, and stop within shorter time, shorter period of time. So the same goes here. Diagram 3.2, okay, took a longer time to stop spinning. Clear? So your answer, as usual, we don't talk about the way they ask paper 3. This is very common, all right? But you know that you are going to use hacksaw blade, okay? Because they will tell you, all right, and give you the clue of what apparatus to use, all right? Then you notice that they give you what? Hacksaw blade here, all right? Hacksaw blade, all right? They give you here G clamp, all right? They give you here apparatus, other apparatus, boleh? All right. So the suggested answer that you can give will be understood. All right. Okay. You know we are going to use plasticine. All right. You're going to use plasticine. Betul? All right. You know that you're going to use plasticine again. Boleh? All right. And what else? Hacksaw blade. All right. Okay. So let's take a look at variable first. Huh? Okay. All right. Mass understood is the manipulated. Responding, you should put inertia, but you cannot measure inertia. So you measure what? Period of oscillation. If you want, you can put a bracket there, all right, and tell examiner, this one actually represent inertia. Tidak salah. Dalam bahasa, adik boleh tulis, all right, okay, tempo ayunan, okay, mewakili inertia, okay, inertia, okay, represent inertia of the object, okay, boleh, mewakili inertia. The constant variable understood, you use length, okay, all right, or you can use the word flexibility, up to you, all right, okay, and then we're going to take a look. So I did tell you manipulated mass, period oscillation, all right, period oscillation, responding, these two must appear in your aim, all right, to investigate relation between the mass, right, the mass, mesti wujud, all right, yeah, sometimes it'll be better for you to complete it, the mass of the plasticine and the period of oscillation of the plasticine, all right, and it must also appear in your hypothesis. The higher the mass of the plasticine, all right, the greater, right, the greater the period of oscillation. Clear? All right, and then understood. I always tell you, okay, manipulated you put in front, manipulated variable put in front, all right, responding variable you put at the back, betul? And responding variable you put at the back, and put the word what? Affect A, affect B. Manipulated variable affect responding variable. Okay, in bahasa jisim, okay, jisim objek, okay, mempengaruhi inertia. Alright, inertia sesuatu bahan. Alright, affect the inertia. This one actually no need to write. Okay, no need to write. Okay, this is actually wrong. This is actually wrong. Okay, you are not supposed to write plasticine. Alright, because the original diagram. Alright, because this is a general answer that I get from somewhere. All right. Okay. So based on diagram, it is not plasticine. You got to write just now the blade just now. Okay. All right. What blade? Then you refer back to the words they use. All right. What blade is that? What blade? All right. What blade is mentioned here? All right. Bell blade. Do you see the word here? Bell blade. Then you put back the word. All right. The mass of the bell blade. All right, the mass of the bell blade affect the inertia of the bell blade. All right, the inertia of the bell blade. Boleh? All right, this is your responding variable. All right, this is going to be your responding variable. Boleh, huh? So I hope you are able to follow. Don't worry. All right, you have another choice afterwards. Okay. Kalau ini keluar, jawab ini if you feel comfortable. So as usual, hacksaw blade semua ini mesti mau stopwatch. Alright, stopwatch. Why? Time period. Plasticine, different mass. Alright, to show different inertia. And this diagram, okay, I'm sure you have seen this diagram before. Betul? Alright, and the following one, understood, procedure. Then procedure, I leave it empty because it's different question. Then you're going to say, alright, a clump of plasticine with a mass of 20 kilogram, okay, is stuck onto the end of the hacksaw blade. All right. Okay, there's the first sentence. First sentence, you always talk about manipulated. All right. I repeat, a mass of 20 grams of plasticine is stick to the end of the hacksaw blade. And number two, all right, hacksaw blade, then it will be number two, talk about what? Responding variable. Okay, hacksaw blade is displayed so that it oscillates. All right, and the time taken, all right, and the time taken for 10 oscillation is recorded. Okay, the time taken for 10 oscillation is recorded. All right, and the experiment is repeated, okay, 2 times. All right, to get average. Okay, you can mention that. And the third one, understood, your sentence, third one, will be talking about repetition. All right, okay, repetition. So your sentence will sound like this. The verb steps are repeated by increasing the mass of the plasticine to 40 gram, 60 gram, 80 gram, and 100 gram. All right, and corresponding time for 10 oscillation is recorded. Full stop. After that, the last sentence, you can talk about this. All right, the period of oscillation of each mass of plasticine is, okay, calculated and obtained. Clear? And then you show this table of tabulation, they will earn you, all right, they will earn you, okay, 1 extra mark, okay, because tabulation is always 1 mark, right? Tabulation is always 1 mark. And the last one, understood, okay, you can put your mass, all right, understood, always x-axis manipulated variable, and responding variable will be your y-axis, which is the what? The period of oscillation. Clear? That is the end for the prediction of question number 1. I will go to prediction of the question number 2 at the end of our lesson, all right, of our revision today. All right, shall we go back? All right, shall we go back? Okay, we have approximate, okay, 16 slides to finish. All right, when we have approximate 16 slides to finish, it's good news. All right, we don't have to wait. I can finish within 2 hours exactly, or less than 2 hours. All right. Okay. Boleh? Is it okay? Can we continue with our next prediction, next revision? Boleh? This is also electromagnet. All right. Okay, it is also electromagnet. I give a lot of electromagnet and also electricity because it's a very, very popular question. Okay. Boleh? Let's move. Okay. Can you please read the question first? Right? Can you read the question first? If there's any question you want to ask, okay, you can probably put your comment, huh? All right, I can see in my tablet or what, any question you want to ask, all right? Okay, I believe if you do have nothing to ask, then of course, there will be nothing for me to see, all right? Okay, if there's any question, please ask, all right? Any question you want to, all right, you want to clear, all right? And any question that you are unsure, all right? Then please, okay, please feel free to ask. Okay, please feel free to ask. All right. Okay, anything about hypothesis or inference or anything that you want to ask, let's take a good look. Okay, we continue now. Diagram show dynamo. This is dynamo. All right, question talk about dynamo connected. Remember, it's talking about dynamo. You're going to use this experiment. All right, you're going to use this experiment. All right, milliammeter or milligauss-meter. All right, and then you're going to have the coil. All right, you can draw your coil bigger, and then you're going to allow the magnet to fall down. All right, definitely it will be this one, north and south. All right, okay, and understood when the rotation is faster. All right, when the speed of rotation is faster. All right, understood. All right, the dynamo will generate higher current. So that means that you're going to put the magnet higher, at a higher height before you let it drop. Okay, but if you're talking about a lower speed, then you're going to put the magnet at a lower height. Betul? All right, you know what we are talking about. It's good, right? It's good if you know what we talk about. All right, let's take a good look. The diagram show dynamo which is connected to a bulb. It is found that when bicycle wheel rotates slowly, the bulb will light up dimmer. So understood, slow connect to dim. All right, and the bulb is brighter than usual when the bicycle wheel is rotated with a higher speed. All right, why? Because the dynamo is connected. All right, dynamo is connected. All right, this is the dynamo. It is connected to the wheel. All right, it is connected to the wheel. All right, when the wheel rotate higher speed, understood, dynamo will rotate higher speed. So inference, understood. Okay, inference, then you talk about, okay, one dimmer, one brighter, then you talk about brightness. Betul? All right, and then they show the word what? Slow and fast. Slow and they use the word speed. You may talk about use the word speed. Clear? You may use the word speed. You may use the word brightness. See what is given there. All right, but this student changed to the word velocity. So you are not supposed to use any scientific term. All right, speed, yes, because it is given. It is given in a question. So speed is okay. All right, the speed of the rotation of the wheel affect the brightness. I repeat, the speed of rotation of the wheel affect the brightness of the bulb. Is okay. Clear? Can we move on? All right. So when you are not given velocity, please don't use velocity. Boleh? Speed, okay. So manipulated, understood. Then the same problem, you're not supposed to use, okay, let me change the color. You're not supposed to use velocity. You're supposed to use the word speed. All right. Okay. Speed. You see or not? And you cannot measure speed. You cannot measure the speed of the magnet. So what do? You tell examiner represented by the height. All right. And also brightness. You cannot measure brightness. Also cannot measure. That's why you measure the magnitude of induced current. Agree? How much current induced. That's why I draw the diagram. Milligalvanometer or milliammeter. So height represent the speed and induced current represent the brightness, because brightness is not measurable. And as usual, constant variable number of turns in the coil and the diameter of the coil. All right, or means you use either one will do. Okay, let's move. Hypothesis, understood. You must mention, use back the same word, use back, okay, the same word speed, and use back the same word induced current. All right, okay, speed and induced current. Betul? All right, the higher the speed, okay, the higher the induced current. You see or not? I stick back to the word I have chosen. All right, I stick back to the word I have chosen. I cannot, simply use what I like, velocity. I cannot simply use what I like, brightness of the bulb. Why? It's not measurable. Clear? All right. Then aim also, you use back the same word. All right, you should use back the same word speed and also induced current. All right, so you should put in the first blank the speed of rotation or speed of the magnet, and the other one will be induced current. Betul? All right, aim and understood. Then list of apparatus. All right, list of apparatus. Okay, we take a good look and see what is missing. All right, there's nothing to measure current. Betul? You see or not? There's nothing to measure current. All right, there's nothing to measure current here. Betul? So when there's nothing to measure current, okay, you need to put in current. Betul? You need to put in current. All right, you need to put in what to measure current. Either it's a milliammeter or milligalvanometer, up to you. All right, okay, it's written there sensitive. All right, it's written there sensitive. Milli, okay, it's written there sensitive. Boleh? Boleh, eh? Yeah, let's make a progress here. Arrangement of the apparatus. Okay, understood. What is missing? You cannot use bulb. Bulb you cannot measure. If you use bulb, sure, habislah. You are telling examiner you do not know what to use. All right, you do not know what to use to measure. Betul tak? All right, if you do not know what to use to measure, then susah lah. Betul tak? All right, so make sure you know what to do and make sure you know what to give. Betul? All right. Can I move on? Can I move on? All right. If you can move on, then it's good. All right. Boleh ha? Hang on, huh? Hang on. Wow. Okay. I think it's a wrong arrangement, huh? All right. Okay. We do this. We do the arrangement first. Then the procedure. Okay. Yes. Correct. There's nothing wrong. All right. Okay. Take a look at the first sentence. This is not needed. If you put the first sentence there, you are actually wasting your time. All right. There are lots of students who will write this sentence. I always tell them, don't write sentence that doesn't give you time. That doesn't give you marks. Betul? All right. And then understood this is wrong. You are not able to measure brightness. Betul? Because you're going to use what? Sensitive galvanometer. All right. Next, sensitive galvanometer. We are using sensitive galvanometer. And that's why you can measure the what reading. Betul? All right. So the first sentence, ada markah, tulis sana. Second sentence, maximum. Okay. Maximum reading. Okay. All right. Maximum reading. Betul? Okay. Maximum reading of the induced current, of course. Okay. Maximum reading or maximum induced current. Okay. Then procedure repeated. We change the height, 5 cm to 10, 10 to 15, 15 to 20, 20 to, all right, 20 to 25. Hang on, I go back. Wow. Okay. 20 to 25. And the corresponding value of induced current is recorded. Is it okay, people? All right. If it's okay, we will move on. Huh? All right, we move on. We won't be wasting time here. All right. So what's wrong with this? Speed. We cannot measure the speed. All right. We measure the height. Okay. Boleh, huh? All right. So what is the correct one? Okay. It should be the height and the induced current. Any problem with this? Before I move to the next one? Boleh, huh? Hmm? Okay. We have maybe a question. People asking question. Oh no. You see, Alicia Wong say okay. All right. Alicia Wong say okay. All right. Let's move on, huh? Let's move on. All right. I thought Alicia is asking something. All right. So what's wrong with this? What's wrong with this? The same thing, right? Okay. The same thing. What is that? What is it? Brightness. Okay. You cannot measure brightness. This will be current, right? Okay. This will be current, right? Agree? Agree? Let's see what is written there. It doesn't come out. Yes, current, ampere. All right. You cannot measure brightness. If you measure brightness, you are looking for trouble. Okay. All right. So let's move to the next one. We almost come to the end. This is question number 6. All right. As an engineer, right? We almost come to the end. As an engineer, you are assigned to study the characteristics of radioisotopes. All right. Let me see. Okay. Let me see how many slides do we have. All right. We have around 1, 2, 3, 4, 5, 6, 7, 8 slides. Okay. So 8 slides understood. Then we will try to fit in our prediction for number 2 at the end of our revision here. All right. You are assigned to study really characteristics of radioisotopes that have different half-lives to be used as a tracer to detect leaks. All right. What is meant by half-life? Okay. See the answer given. What's wrong with this? Oh, all right. Since when you study half-life is the time taken for it to reduce to 0. This is wrong, right? Okay. You know it should be to half. Right, to half of its original value. Okay. All right. Boleh? Boleh ha? Let's take a look at the answer. Half-life is the time taken for the mass of the sample of the radioactive substance to become half. All right, to become half. Okay. All right. Okay. Using a decay curve, describe the change which occur. You know the decay curve is always going down, right? It's inverse proportional graph. So, all right. What's wrong is this? All right. What's wrong with this? Okay. Using a decay curve, describe the change which occur in the nucleus of a radioactive substance during a decay. All right. Okay. Because you didn't do the labeling. All right. Yeah. You only start with N, but you never show. All right. It need to go to half. All right. You need to go to half of the original N. And then you need to also show the time. All right. You didn't show here. Then you didn't show here is considered not correct. Betul? All right. It's considered not correct. Okay. So in other words, you need to show in your graph the actual way of getting the half-life. All right. The actual way of getting the half-life, if not, is considered incorrect. So from N to half N. All right. From N to half N and the corresponding time. All right. Then you need to have one sentence. The activity N decrease to, all right, half. All right, to half. Okay, its original value. Okay, is the time of its half-life. This is the error. Huh? Is the time. Okay, is the time of its half-life. Boleh? Is okay? Then we move on. Huh? Okay, if possible, then we move on. All right, explain the suitable characteristics of the radioisotope to be used for detecting leaks. All right, leaks. Leaks from where? Kita baca soalan. All right, leaks from underground pipe. Okay, from the pipes underground. Okay, understood. Okay, leaks. Yeah. All right, it could be a water pipe. It doesn't mention. It doesn't mention what pipe. All right. So we know that, okay, we will not be able to use very long half-life. If we use very long half-life, it will affect human. Betul? All right, because, all right, okay. Oh, sorry, we go back. Okay, we have to use short half-life. If long half-life, then you affect a lot of human. Okay, emission radiation. Okay, we know that it must penetrate. All right, penetrate the metal underground pipes. Metal underground pipes, understood. We can use alpha. Alpha is 2. Alpha is too weak. All right. You can probably use okay. Alpha cannot penetrate. All right. You'll probably use gamma or beta. Betul? All right, gamma or beta. So understood. Okay. So the short half-life is going to be this and this. All right. And then gamma. All right. Beta. Okay. Beta. All right, beta. You know, some question they probably allow you to use beta, but it normally cannot penetrate. State. Normally we don't use gas. All right. We add into the what? Into the water piping underground. All right. Okay. Either it is going to be liquid. All right. Okay. We don't use gas. And solubility. Understood. We need it to be soluble in water. Otherwise, all right. It will not. The water will not be able to carry. All right, water will not be able to carry. So you could see the answer is going to be R. All right, let's take a look at the answer. All right, long half-life, understood, is definitely wrong. We need short half-life. Explanation is wrong. It can stay long enough in the water. Beta, right? Yeah, beta is also wrong because it cannot penetrate, isn't it right? Right, cannot penetrate. Okay, here is written easily detected. All right, gas, understood. This is also not good. All right, lighter to handle portable. All right, but actually gas is more dangerous. Okay, all right, it's probably easy for it to leak, bocor. All right, maybe the last one is a correct statement. Okay, all right, but your explanation is not good. All right, explanation is not good. You probably say that so that it can dissolve easily in water. All right, in the underground piping. Let's take a look at the answer. All right. Remember half-life, it must be short. All right. Activity will decrease to a low. Okay. Low. All right. Or safe level. Okay. We don't want it to affect human life. So we want it to go to low level or safe level. All right. After a few hours so that it would not cause any health risk. You remember what I mentioned, gamma? This must be strong enough. All right. It has a high penetration power. All right, high penetrating so that it can penetrate through the, all right, it can penetrate, okay, it can penetrate easily. All right, it can penetrate easily. Sometimes it is buried deep in the ground. All right, then understood, we use liquid. All right, liquid, easy to handle and to contain. All right, also easy to be carried around. All right, understood. Last one, high solubility. All right, it can be easily dissolved. So answer, all right, okay, answer understood. Okay, the choice just now. Remember, we choose this and this and this and this. All right, okay, we have this and this. All right, we have gamma. All right, and then we have short half-life. So we know, okay, the most number of tick will be R. That's why your answer is going to be, all right. If you just say R is selected, understood, okay, you will get 1 mark only. You need to explain, all right. Okay, determine the most suitable, okay, and then you need to explain here, justify. So you just repeat, okay, you just repeat what we have chosen. Short half-life, all right, higher penetration power, all right, right, no, gamma, you just mentioned gamma is chosen, all right, sorry, we go back, okay, it has got short half-life, okay, gamma ray is chosen, right, okay, it exists in the form of liquid and is highly soluble in water. All right, it's highly soluble in water. Boleh? Okay. So we almost reached the end of our revision. All right. Okay. I didn't do any revision for chapter electronic because that is a very, we call it, not very hot question. Yeah, but calculation you need to know a little bit. All right. Based on the graph, let's continue. All right. I believe we have 3 more slides to go. Based on the graph, determine the half-life. So understood from 80. All right, number 80, then you're going to let it drop to 40. So the half-life is going to be 1 year. Betul? And you can do it another way around, 40 to 20. All right, 40 to 20, 1 year to 2 years is still 1 year. Betul? The difference of the time. So here is written 2 years, definitely wrong. Betul? All right, half-life is 1 year. When activity of the sample equals to half of its original, of its initial value. Therefore, half-life is 1 year. So remember 1 year because we are going to use this value for the next question. All right. If the initial value initial mass of the radioactive substance is 100, calculate after 5 years. So half-life is 1 year. So 5 years, it will decay 5 times. All right. So if you are good, then you should start with 100 and then you should draw 5 arrow. 1, 2, 3, okay, 4, 5. And this will be your answer. Okay? And we know 100 will drop to 50. 50 will drop to 25. 25 will drop to 12.5. Betul? All right, 25 will drop to 12.5. Okay, 12.5 will drop to what? 6.25. 6.25 will drop to 3.125. So you will expect your answer to be 3.125 gram. Okay, see what is the answer given. All right, so answer given 5 gram. That's why you see a sour face here. Betul? All right, this is the answer given because we have 5 years, which is equivalent to what? Equivalent to 5 half-life. Betul? All right, equivalent to 5 half-life. All right, let's move. Okay, this is the end of our last minute seminar for physics. So I hope you will be able to get a very good last minute revision. Okay, all right, for physics. And hopefully what we do will be able to help you and guide you to make sure, all right, you are able to grab a better grade, okay, right, in your SPM exam. All right, hopefully things become clearer and better to you. right? If let's say you are not very clear about certain parts of physics paper, all right, you are most welcome to ask, all right? And let's move out from here. I'm going to do the prediction for paper two, paper three, all right? Let's hang on, give me 1 minute, okay? Give me 1 minute. I'm going to open the file and share with you, all right, what will come, okay, for the next one. Just give me 1 minute, huh? Give me 1 minute. All right, for the second one, all right, second prediction, it will be this one, all right, and some of you probably have seen it, all right, it's talking about a drill, all right, okay, can you please read? Can you please read the question there, the sentence there? Can you please read? All right, can you please read? Okay, let me recap, huh? All right, diagram is showing electric drill, all right, okay, electric drill, bit is spinning in a minimum current. Why minimum? Because here you notice it's darkened. All right, button number one, just like our wall fan, right? Just like our wall fan, darken button number one. All right, and the next one, diagram 4.2 is showing you the same electric drill spinning faster. All right, at a maximum current. And you notice that is number three, button number three. So it's working on the principle of motor. So next time, if you're going to come up with any question which give you the idea of the usage of motor, the answer will be the same, huh? All right, you'll be using the what we call a C-shaped iron yaw. All right. So example of instrument that uses motor, there are so many. Number one, right, a simple wall fan or table fan. All right. Number two, all right, even hair dryer. All right, hair dryer. Okay, hair dryer, anything that rotate. Okay, all right, anything that rotate. Okay, and understood. We are talking about the drill in the diagram here. All right. Okay, and number four. Okay, let me think about. Let's say when your mother make any cookies or any cake. All right, your mother will probably use this machine known as the beater. Okay, it will go and turn around. It will beat the how should I say, the dough. Okay, or the flour. All right, it will beat the flour and the mixture of everything. All right, we call it beater. Okay, all right. Okay, anything that spin. So the list will actually goes on. Just think of anything that spin. All right. Then anything that spin that uses current, it will be using the concept of what? Motor. When you use the concept of motor, meaning what? Then you will be using the same answer. All right. Okay. Do you see or not? You take a good look. All right. They will even tell you. All right. Using the apparatus such as C-shaped iron yaw, magnet, and other related apparatus. Describe the experiment. Okay, this is a second prediction that I think will come out. All right, just watch. All right, and let's take a good look at the answer predicted. All right, okay, all right, this is the answer. I give similar question to the students in year 20, okay, in year 2018. All right, in year 2018. All right, which was 2 years ago. All right, okay, let's take a good look at the answer, and you notice that something is wrong there. Okay, let's focus. Okay, let's focus on the answer given by this particular student. All right, let's focus. Manipulated refer to the current. Okay, yes, correct. Current they flow. That's why the word current. Okay, these students will be given 1 mark here. All right. Okay, and we know, all right, motor. We are supposed to measure the speed, but we cannot measure speed. So instead of measuring speed, which is not measurable, we will use the word displacement. This is the word, okay, displacement of the bare copper wire. Bare copper wire. You take a look at the diagram. You will see the copper wire. You see, the bare copper wire in the diagram. Notice that. Notice. I'm sure this is not the first time you see this experiment. All right. So be careful, huh? All right. If my prediction comes out correct, you'll be laughing away, okay, while doing your work. Boleh? All right. Okay. Menjawab soalan fizik kertas 3 sambil jawab sambil tersenyum. Okay. All right, huh? Okay, this is only prediction, huh? All right, it's only prediction. All right, and let's take a good look. Okay, constant variable, the strength of magnetic field. Yes. All right, correct. Strength of magnetic field diterima. So you got 1 markah, 1, 1, 1. Okay. Then we go to what? The aim. After C part 2, we go to C part 1. All right. Normally, that's how I ask the student to answer. You write A first. Okay, that's how you answer. Huh? All right, you write A first, leave it empty. You write B, leave it empty. You write C part 1, leave it empty. You do C part 2 first. After you see part 2, after you have done C part 2, all right, after you have done your manipulated, you have done your responding, you have done your constant, then you go back to C part 1 to investigate relation between your manipulated, all right, manipulated put here, and all right, your responding put here. Okay, responding put here. All right, and then you get 1 more mark. Boleh? But these students, when it comes to hypothesis, your manipulator correct. Manipulator correct. Current, yes, correct. Manipulator correct. But responding dia tulis benda lain. Responding dia tulis false. Okay. So kalau responding you tulis false, your responding is supposed to be displacement, betul? Responding variable supposed to be displacement. You hantam false memang salah. All right, because the force that you put is not measurable. How are you going to measure the force? It'll be very hard for you to measure the force. Betul tak? All right, that's why dia hilang markah. Ini tempat tak ada markah. All right, okay. Then your inference current. You see butang pertama, butang 1 harus lebih kecil. Butang 3 harus lebih besar. So the current, okay, current that flows to the motor effect. All right, okay, current. Okay, that is your manipulated. All right, manipulated effect, responding variable. All right, responding. This is okay because your original diagram may show you the concept of force. All right, may show you the concept of force. Ini boleh diterima. Boleh? Lepas itu, look at diagram. Look at your apparatus and diagram. Okay, and examiner will check. All right, check like this. DC supply. Okay, ada. C-shape iron yoke. All right, yes, ini ada. C-shape iron yoke. Bare copper wire. Ini ada. Bare copper wire. All right, connecting wire. These are all the connecting wire. You see or not? Okay, connecting wire. Ini pun connecting wire. You can also put connecting wire. All right, a ruler to measure the displacement. Ammeter. All right, ammeter memang ada sini. All right, ammeter. Betul? Okay, Oh, actually one thing is missing from diagram, this student didn't draw rheostat. All right, he should come up with a drawing of the rheostat here. Okay, okay, rheostat should be put here. Okay, I put it there, rheostat. It's not so what? Okay, because lukisan. All right, then with arrow. Faham rheostat? And then label. Okay, you need to do the label. Why rheostat diperlukan? Because you're going to use it to change the current. Understand? Rheostat. Rheostat tak ditunjukkan. Betul? So sepatutnya ini murid akan, okay, maka ini murid tidak akan dapat. Alright, tidak akan dapat. Clear? Alright, and then let's take a look at your procedure. Alright, very simple. You see the procedure, I always tell students, make it short, make it simple. Alright, make sure your first sentence, you are going to talk about manipulated variable. Alright, manipulated variable, masih ingat? Manipulated variable is current, betul? Alright, ammeter supply is adjusted using rheostat lah. Is adjusted until it reaches 2 ampere, 0.2 ampere. All right. The displacement, this will be your responding variable. All right. Responding variable. Okay. Second sentence. Responding variable, which is your displacement. All right. Is measured using ruler. All right. Understood. Okay. No need to write the first sentence. All right. And okay, it's recorded. Okay. And it's recorded. Just continue. All right. The third sentence will be your what we call repetition. All right. The next sentence. All right. Repeat. Okay. Experiment. The step repeated by adjusting the rheostat. Right. Adjusting the rheostat so that the current that flow is 0.4, 0.6, 0.8, and 1 ampere. It must correspond with your table. Understand? Let's take a look at the table. So this student will get 1 mark here, 1 mark here, and 1 mark here. All right, but this candidate can further improve bila dia menulis. Okay, rheostat dilaraskan. Rheostat dilaraskan untuk mengubahkan nilai to increase the current that flow through the circuit to 0.4 ampere, 0.6 ampere, 0.8 ampere, and 1.0 ampere. Manipulated is your first column. All right, responding, displacement. All right, will be your second column. So when these are correct, then understood. 1 more mark here. All right, and the last one is going to be the graph. Clear? All right, repeat. Okay, sorry, not R. All right, it should be M. Manipulated variable. All right, current. All right, responding variable. Okay, responding variable. Displacement of copper wire. So you can just write a statement, a graph of displacements of the copper wire against current is being plotted. All right, without any graph, actual graph on the graph itself, just the axis. All right, just the y-axis and the left axis and the x-axis, then you get 1 mark. So when we total up this candidate, she's getting 12 out of 13, right? Okay, by right, she should be getting around 11, right? Because I missed the rheostat. Okay, so rheostat mesti diberi, huh? All right, rheostat mesti diberi. So I think I've already spent 1.5 hours. Okay, 1.5 hours with all of you. All right. Okay, I guess you should be how should I say well prepared. Okay, you should be well prepared for your SPM because I touched on all the important aspects and prediction for 2 questions already given. One is electricity, concept of motor, right? Concept of motor. And the other one is going to be what we call inertia, right? Inertia, concept of the period of oscillation of the hexagon blade. All right. So with that in mind, all right. Okay, with that in mind, I hope that whatever I have given to you, all right, whatever I've given to you will be able to, okay, to a certain extent, able to help you, all right, to be prepared fully for your SPM. All right. So if you think that whatever I predicted happened to be accurate, please, spread the news around. All right, spread the news around. Okay, because I have been predicting accurately whatever question that comes out. Okay, in paper 3, right, based on the analysis. All right. So with that, I'm going to come to the end of our how should I say last minute revision. All right, an additional program, okay, to help you to be well prepared for your paper physics. Okay, all right, physics paper for SPM level. All right. Okay, so wish you all the best. Selamat menduduki peperiksaan SPM. Follow the SOP to make sure you are always healthy. All right, and follow whatever procedure. All right, I see you then. I hope you will be well prepared for paper 3. Huh? So my wish is every one of you can do paper 3 accurately and correctly. Make sure you don't miss the rheostat. All right, rheostat is always used to measure. Sorry, always used to change the resistance. When you change the resistance, you actually change current. Clear? Right? Okay, you are making use of rheostat to change resistance in order to change the value of the current flow in the circuit. All right. So with that in mind, all right, I will pass the mic to our, or should I say, MC or our organizer, which is Mr. George. All right.
All right. Thank you, Mr. Lee, for the sharing. I know that the first paper is tomorrow, BM, Bahasa Melayu. So without any further ado, that's all for our seminar for this 2 days sharing of physics paper. So we hope that it can help you to do more preparation before you sit for your physics paper. Once again, thank you very much for joining us. If we have any last minute tips that we are going to share, we'll share inside our WhatsApp group, Telegram group, and so on, to spread the news to all of our students. Okay, so that's all for our seminar for this 2 days physics sharing session. All the best in your SPM. Selamat menduduki peperiksaan SPM buat semua murid. All the best to you. May the force be with you. Thank you very much, and we will see you again when I see you. All right, that's all. Thank you. Bye bye, guys.